Hey there! Did you know that electrical circuits power nearly every device in our modern lives, from smartphones to refrigerators and everything in between? Well, today we're going to delve into the fundamentals of electrical circuits and master the basics in just one day. Yes, you heard that right, one day. So let's get ready to demystify circuits, uncover their secrets and see how easy they can be. Welcome to our channel where learning meets fun. Our mission is to make complex topics like electrical circuits approachable and exciting for everyone. No matter your background or prior knowledge, we're here to guide you every step of the way. So sit back, relax, and let's embark on this electrifying journey together. Let's address something. Many people believe that electrical circuits are too complex to grasp. It's like trying to understand a foreign language without any guidance. But fear not, because understanding circuits is simpler than you might think. With the right approach, you can master the basics in no time. This video is all about breaking down those barriers and showing you that you don't need to be a math wizard or an electrical engineer to understand the magic behind circuits. We'll use simple language, real-life examples, and hands-on demonstrations to bring the concepts to life. You'll be amazed at how much you can learn in just one day. Think about it. When was the last time you felt like you couldn't understand something? Maybe it was a new technology or a complicated rule. But did you give up or did you seek help, learn from others, and practice until you got it right? The same goes for electrical circuits. Don't let the complexity intimidate you. Embrace the challenge, stay curious, and you'll be surprised at what you can accomplish. And here's the best part. Learning about circuits isn't just theoretical. It has practical applications in everyday life. Whether you want to fix household appliances, work on electronic devices, or simply understand how the gadgets around you function, this knowledge is invaluable. Plus, understanding circuits opens doors to exciting possibilities. You can create your own projects, build innovative devices, and even pursue a career in the field of electronics. All right. We've set the stage, and now it is time to turn on the lights and illuminate the path to circuit mastery. Get ready to explore the basic concepts that form the foundation of electrical circuits. We'll look at three key elements: voltage, current, and resistance. These are the building blocks of circuits, and understanding them will unlock the door to circuit comprehension. First up, we have voltage. Think of voltage as the driving force behind the flow of electricity. It's the energy that pushes the electrons through the circuit. Imagine a water balloon. The higher you hold the balloon, the more potential energy it has. Similarly, a higher voltage means a stronger push for the electrons. Now, if you release the balloon, water will flow from a region of higher potential energy to a region of lower potential energy. Likewise, electrons will flow from a point of higher voltage to a point of lower voltage. This flow of electrons is called electric current. Speaking of current, did you know that the flow of electrons in a circuit is often compared to the flow of water in a pipe? In this analogy, the electrons are the water, the wires are the pipes, and the voltage is the pressure that drives the flow. It's a pretty neat way to visualize how electricity works. But wait, there's another important factor that affects the flow of current: resistance. Think of resistance as the friction that opposes the flow of electrons. It's like putting a strainer in a water pipe. The narrower the pipe or the stronger the resistance, the harder it is for the water to flow. Similarly, the higher the resistance in a circuit, the harder it is for the current to flow. Now here's where things get really interesting. The relationship between voltage, current, and resistance is like a balancing act. When voltage increases, the current also increases, assuming the resistance stays the same. This is known as Ohm's law, named after the German physicist Georg Simon Ohm, who discovered this relationship. But when resistance increases, the current decreases, again, assuming the voltage remains constant. It's like a seesaw. If you increase one side, the other side goes down to keep it balanced. So why does this matter? Because understanding this relationship is key to analyzing and designing circuits. It helps you predict how changes in voltage or resistance will affect the current in a circuit, and vice versa. For example, If you're working on an electronic device and notice that the current is too high or too low, you can adjust the voltage or resistance accordingly to achieve the desired result. But wait, let's not get ahead of ourselves. We've introduced some important terms and concepts, but we haven't put them together to form a complete picture of an electrical circuit. That's what we'll do next. Get ready to witness the birth of a complete electrical circuit. It's time to put all the pieces together and see how they form a complete electrical circuit. Let's start with a simple circuit consisting of a battery, wires, and a light bulb. A battery is like the fuel tank of an electric car. It stores chemical energy that can be converted into electrical energy. The battery has two terminals, a positive terminal and a negative terminal. The positive terminal is like the starting line for the electrons. When connected to a circuit, electrons flow from the negative terminal to the positive terminal. Okay, but how do the electrons travel from the battery to the rest of the circuit? That's where the wires come in. Wires are like roads for electrons. They provide a pathway for the flow of electric charge. Different materials conduct electricity to varying degrees. Some materials like rubber and glass are good insulators and resist the flow of electrons, while metals like copper and aluminum are excellent conductors. The choice of wire material depends on the specific application and the level of conductivity required. Now, how do we make the electrons do something useful like light up a bulb? That's where the light bulb comes in. A light bulb is a device that converts electrical energy into light and heat. When electrons flow through the filament of a light bulb, they encounter resistance. This resistance causes the filament to heat up, which in turn emits light. Voila! We've completed the circuit and made the light bulb glow. Let's take a closer look at the circuit we've created. Notice that the flow of electrons from the battery to the light bulb and then back to the positive terminal of the battery forms a closed loop. This closed loop is what we call a series circuit. Series circuits are simple and effective, but there are other types of circuits like parallel circuits that offer different advantages. In a parallel circuit, multiple paths are available for the electrons to flow, creating multiple loops. Parallel circuits have their own unique characteristics and applications. For example, in a parallel circuit, if one component fails, it doesn't affect the rest of the circuit. In a series circuit, however, if a component fails, it breaks the entire circuit and stops the flow of current. As we continue to explore circuits, you'll discover even more fascinating concepts such as series and parallel combinations, circuit diagrams, and various electrical components like resistors, capacitors, and inductors. Each new concept adds another layer of understanding, allowing you to analyze and design more complex circuits. So remember, the journey of 1,000 miles begins with a single step. In this case, that step is understanding the basic concepts of voltage, current, and resistance. With these building blocks in place, you're ready to tackle more advanced topics and unravel the complexities of electrical circuits. By the way, if you're enjoying this content, don't forget to hit that like button and subscribe to our channel for more exciting science and tech adventures. Your support keeps us motivated to create more awesome videos for you. And speaking of hands-on exploration, here's a question for you to ponder. Think about a time when you encountered a technical issue with an electronic device or an appliance. How did you troubleshoot the problem? Did you try to understand the underlying circuit, or did you simply call a professional? Share your experiences and thoughts in the comments below. We'd love to hear from you. Also, don't forget to tune in next time when we'll delve deeper into circuit design and explore more advanced concepts. Keep your curiosity alive and your mind open, and you'll be amazed at what you can discover. Thanks for joining us on this electrifying journey into the world of electrical circuits. We hope you've gained some valuable insights and maybe even discovered a newfound appreciation for the invisible forces that power our modern world. Remember, the more you understand about circuits, the more empowered you'll be to solve problems, create innovative solutions, and navigate the ever-evolving world of electronics.